Okay, so today we are going to talk about the configuration stuff, main stuff, very important thing. Most of the people don't know this, like the people working on NetApp. Okay, so normally I told you, right? uh, okay, okay, let's talk about, yeah, RDB, or normally in 7 mode, or if it is a C mode also. Okay, we'll be having root aggregates. I told you, right? We have every controller will have its own root aggregate. So in that root aggregate only, the controller configurations will be stored, right? So in 7 mode also, we'll be having root aggregate, which is by default, we'll call it as AGGR0. Okay, that is the name of the root aggregate. So inside the root aggregate, okay, we will be having a root partition, a logical partition. Again, this logical partition also will be created during the cluster setup only, just like how root aggregate got created. Okay, along with root aggregate, once the root aggregate is created, automatically ONTAP will create this logical partition as well. Okay, for now, let's assume this is a root partition. And when it comes to NetApp term, we'll call it as volume. Okay, we'll call it as a root volume. I can say that. We'll talk about volumes more in maybe tomorrow or day after tomorrow's class. Okay, so the volume name will be vol0 by default. That is the default name which will be given by ONTAP to this particular volume. Volume means nothing but a logical partition inside root aggregate. Okay, sorry, inside aggregate actually. This is a root volume which will be stored on root aggregate. So on top of root aggregate, we'll be having a root volume, and in this root volume only, our controller configurations will be stored. And again, in root volume, inside this root volume, we'll be having a folder called etc. Okay, we'll be having a folder called etc. Under etc, our controller configurations will be stored. Okay, this is a folder. This is a folder directory, or else you can say that. Okay, we'll be having a lot of configurations such as RC file, um, resolve.conf, um, post file, like that. We'll be having lot of configuration files. Okay, normally network related configurations will be stored in RC. DNS related configurations will be stored in resolve.conf and all. Okay, normally whatever configurations that belongs to controller, okay, that will be saved as a files. Okay, and also for NFS we have a file called exports. Okay, like that, we'll be having lot of things, lot of configuration files inside etc, inside vol0 and inside aggregate. Okay, so this is how it is in 7 mode. So whenever you made a configuration change, okay, you first what we'll do it by using a command. But even though if you executed the command, whatever the changes applied via command, those are just temporary. In order to make them permanent, what you need to do, you need to edit these configuration files. That is how it was in 7 mode. It is still, if you are using 7 mode, it is the same way. You need to make the configurations permanent, then you need to edit these files. You need to add those configuration entries in files. For example, you made a network configuration. So in order to save it permanently, you need to edit this RC file. Okay, if you made a configuration change in DNS, if you want to save it permanently, then you need to make a change in resolve.conf file, like that. Okay, this is how it was, or it is in 7 mode. Now let's talk about a cluster mode, how things are in cluster mode. For example, one more thing is, if someone deleted these configuration files accidentally, or if someone tried to edit it and deleted the data inside the configuration file, deleted the content inside the configuration file, then it will be a big problem. So that is a very big challenge to the people who are already who are working on 7 mode. Okay, because you have to be very careful while modifying or editing these configuration files, because if you delete anything unexpectedly, it will show impact on your entire controller configuration. Okay, so that is a too danger to edit these files. Okay, that is the reason, in order to avoid this one, they have introduced a different mechanism in cluster mode to store the configurations. Okay, so same here, in C mode also we'll be having root aggregate. Okay, and inside root aggregate we'll be having root partition or root volume, which is a wall 0 again, same thing. But inside wall 0 we'll be not having any folders or configuration files. Okay, instead of that, they designed a database called RDB, RDB, replication database. Okay, RDB, replication database, that is the full form of RDB. So in this database only, all our controller configurations will be stored. Okay, all our control configurations will be stored in this RDB only. Okay, there is nothing like a files, folders, nothing will be there. It is a simple database where everything will be stored, the controller configuration. So you don't need to edit any file to make the configurations permanent or persistent. Okay, so whenever you execute a command uh, that apply changes to your controller, the command will modify the database automatically. So you don't need to worry about making the configuration permanent by editing files in just like 7 mode. Okay, you don't need to do that. It's pretty simple here. Just execute the command, it will modify the database. That's it. Okay. Any questions, guys, so far? We'll talk about RDB more now, but apart from that, okay. So now let's talk about RDB in detail. So sorry for the disturbance in the background. Okay, RDB, replication database. So again in RDB, we have sub databases. Okay, we have sub databases. The first one is LDB. The full form of VLDB is volume location database. That is the full form of VLDB. So this contains the configuration details of your logical partitions, nothing but volumes. Okay? And along with that, it contains the aggregate information. Aggregate belongs to which node. Same way, the logical partition belongs to which node and which aggregate. These kind of information it will maintain. Okay, VLDB contains volume and aggregate information, which node they are on which aggregate the logical partition or volume is part of. These kind of information will be maintained. Not only that, yeah, these things. Next thing is VIF MGR. The full form is Virtual Interface Manager. Okay, that is the full form. So what VIFMGR maintains, this subdatabase contains all network related configurations. Okay, all network related configurations will be stored in this VIFMGR, will be handled by this VIFMGR. Network things, kind of IPs, ports. Okay, and there are some few components like IFGRPs, if groups. We'll talk about these things later. VLANs, all these kind of configurations will be stored in this VIFMGR. Basically, VIFMGR will host network related configuration. Okay. Next. Next thing is BComDB. The full form is Block Communication and Operational Management Database. That is the full form of BComDB. So what BComDB will do? BComDB will maintain SAN configurations. The things which are related to SAN, everything will be managed under BComDB, will be stored under BComDB. Okay. Next one is MGMTD. The full form is Management Daemon. Okay. So this MGMTD contains management and cluster internal service configurations. This will be handled by MGMTD. Management in the sense of like we have configured management IPs and all, right? Those things will be handled by management daemon only. Along with that, the cluster internal communication services, like the nodes in the cluster will they have to communicate with each other, right? Like these kind of cluster internal operations will be handled by management daemon, MGMTD. Okay. Whatever the internal functionalities and things related to management will be stored in MGMTD database, subdatabase. Next, last one, last but not least, that is CRS, Cluster Replication Service. Okay, and this CRS belongs to metro cluster configuration. Okay, so CRS belongs to metro cluster configuration. For example, if your cluster is not a metro cluster, if your cluster is a normal cluster, then CRS will do nothing. It just stay ideal. Okay, it just stays ideal. That's it. But if your cluster is a metro cluster, then CRS will play a very crucial role to manage the metro cluster configurations and the metro cluster services. Okay. So these are the 5 subdatabases which will be part of RDP. Okay. Any questions, guys?
No, Naveen.
Okay. Cool. Let me save it so that it will be. Cancel it here. I'll upload it to the folder. Did you notice that I have uploaded the documents and these diagrams as well? Some of these documents which are important to the same link which I've shared with you. Okay, you can download it from there. Okay. Next thing is, so normally when it comes to RDB, as I told you, we have 5 sub databases, right? So all ONTAP versions has 5 databases. No, up to, okay, up to data ONTAP 8.2, we used to have only 4 sub databases. Which is the missing one? CRS will be, okay, CRS was not there. Okay, CRS was not there because earlier, okay, earlier mm, to data ONTAP 8.2 and later versions, there is no support of metro cluster functionality in C mode. That is the reason CRS was not there. Okay, the only normal cluster will be supported by C mode. Okay, but from 8.3 onwards, from 8.3 onwards, they have introduced metro cluster functionality. That is the reason they have added this 5th database CRS. Okay, which will take care of metro cluster configurations and functionalities. We have already discussed about metro cluster high level, right? Like what is the purpose and how it will work. Yeah. Guys, metro cluster very minimal, like only like 1% of NetApp customers will use metro cluster because I told you, right, yesterday I have shown you you need to use mirror aggregate and all, which is very expensive solution. Okay, only banking clients, these kind of environments, they'll use the metro cluster generally. Okay. Okay, so yeah, from 8.3 onwards, data ONTAP 8.3 onwards, it is 5 databases. Okay, now let me show you how to find the databases and all. And yeah, sorry, before that, now how RDB will work. Tell you. Let's assume that I have a 4 node cluster. This is my 4 node cluster. So every controller contains RDP, right? I told you already. Oh, sorry. Yeah, every controller contains RDP. RDB on node 1, RDB on node 2, RDB on node 3, and RDB on node 4. So even though we have RDB replication database on every controller, all RDBs contains similar configurations. All RDBs within the cluster contains same configuration. That means, for example, I made a network change on this particular controller, node 1. Then the subdatabase of VIF MGR will be modified in this RDB, and same configuration change will be updated in the other node RDBs within the cluster. Got it? So if you modify any of the configuration within the cluster, the respective subdatabase will be updated on all the nodes. Because all the nodes in the cluster will contain same RDB configuration. Because I told you, right, cluster means group of nodes, and it has to work as a single system. That is the reason all the nodes within the cluster contains same RDP configuration. Okay. And for example, if I created a logical partition on top of third node aggregate, then it will update VLDB database on all the nodes, saying that okay, there is a logical partition or volume got created on top of node 3, this particular aggregate. That information will be stored in or updated in all the node RDB VLDB unit. Okay, this is how the RDB will work. Okay, and generally, okay, in cluster we have one master RDB, remaining all are secondary RDBs. Okay, remaining all are secondary RDBs. One master RDB and secondary RDBs. So we don't know which is a master RDB, but I mean which controller will be elected as a master RDB initially. But when you configure the cluster, initially the first node which you have configured in a cluster will be elected as a master. That is a normal first time setup, and remaining all three, they act like a secondary. Okay, remaining three act like a secondary. So what is the purpose, like what is the advantage of master? Nothing, actually, no advantage. Apart from that, there will be additional burden. So what master has to do, master RDB has to make sure that whatever the configuration changes we are making on the cluster or the resources in the cluster should be updated in all controller RDB subunits. That is the extra burden which has to be taken care by master. Okay, did you got it? Master is responsible for make sure that all the configuration changes we made on cluster or cluster resources has updated on all the RDB units. It is master RDB responsibility. There is no privilege, uh, only there is a responsibility of being a master RDB. Okay. Okay. For example, now let's assume that I'm rebooting node 1. Okay, I'm rebooting node 1, maybe due to some maintenance activity. It might be on tap upgrade, or I'm shutting down the node 1. It is to just replace a faulty hardware. Okay, then this contains a master RDP, right? If master RDP, the node which contains master RDP, if it went down, and during that time if we made any configurations, we are not sure, right? Those configurations are updated across all the node RDBs or not, right? So that is the reason whenever we are rebooting a master RDB, okay, this RDB will move to other RD. I mean, the remaining nodes, one of the RDB in remaining nodes will be elected as a master RDB. Okay, will be elected as a master RDB. Okay, it it might be any node. There is no such a way. It will pick the node randomly as a master. So now let's assume that it picked up node 3 as a master now for RDB units. Okay. Now my controller 1 rebooted and it came up. So will the master go back to node 1? No. From now onwards, only node 3 will work as a master, and node 1 will serve as a secondary only. Okay, until we reboot or shut down node 3 will work or will serve like a master. Okay, you got it? Any questions, guys, on RDB subunits, how they will work? Just let me know if you have any questions. Yeah, cool. Now let's see how to identify the RDBs. So normally if you run cluster and hit tab, uh, sorry, I don't see any option to see it here, right? So in order to check these RDP configurations, we need to go to advanced mode. Okay, to advanced mode, and there is a command called cluster ring show. Okay, cluster ring show. If you run this command, then it will show you all the databases. See, MGMT, VLDB, VIFMGR, BCOMD, CRS. Same thing again, MGMT, VLDB, VIFMGR, BCOMD, CRS. So these all are node 2 RDB subunits, and these all are node 1 RDB subunits. And if you notice here, see here, my node 1 is a master. See, my node 1 is master here, and node 2 is acting like a secondary. Okay, yeah. So this is the command to check it. One more thing, guys. It is not like it is not mandatory that all RDB units must be on the same node. Master, sorry, all RDB master units must be on the same node. It is not like that. You might see some scenarios in your cluster where, for example, only management MGMT, VLDB, node 1 master, and for VIFMGR, BCOMD, and CRS, node 2 is master. Yeah, there are some scenarios where the master RDB units distributed across multiple nodes. Yeah, that can be done. That there are some scenarios I have seen those kind of things. So when it comes to these two particular services, my manage node 1 act like a master. So if you um, edited, or if you modified, or if you updated something related to management configurations or volume aggregate configurations, then node 1 will make sure that it is updated in both the controller RDBs, because for these two units node 1 is my master. VIFMGR, BCOMD, CRS, node 2 is master. Let's assume, I'm assuming that. Then whatever related these things, if you updated any configuration, then node 2 will make sure that those configurations will be updated in both the controllers RDBs. Okay, like that. But here in this scenario, only node 1 is acting like a master for all the sub database units. But there are some cases. Okay, so don't get confused if you see something like that. Nothing wrong. Okay, cool. Now I don't want to start a new topic. Let's talk about a small topics called quorum. Quorum, which is a very important interview question. They'll ask you, like, if they want to test the basics of your storage knowledge, NetApp storage knowledge, then they'll ask you this question for sure. Quorum. So what is quorum? It is a simple condition. Okay, it is a condition that cluster must satisfy for its own survival. Okay, quorum is a condition that cluster must satisfy for its own survival. Then what is the condition, actual condition? Okay, I know that quorum is a condition which has to be satisfied by the cluster mandatory, as a mandatory. Okay, then what is a condition actually? So the condition is more than 50% of resources should be up and running always. So this is the condition. If this condition is satisfied, there will be no problem in your cluster. If this condition is not satisfied by your cluster, then your entire cluster will be go down. Okay, it will be shut down. Okay, so yeah, it is very, very important. Quorum will play a very crucial role. So let me explain you. For example, I have a 4 node cluster. Let's assume that I have a 4 node cluster. After that, 2 nodes went down. One node went down for now. Just let's assume that. Then only one node went down. Remaining 3 nodes are up and running, which is more than 50%, right? More than 50% of my resources are up and running. So no problem. Cluster will be up and running. No impact on cluster. Let's assume 3 of my nodes went down. Obviously, now the resources which are up and running less than 50%. So what it will do, it will shut down this node as well, and it will bring your entire cluster down. Your entire cluster will be shut down and everything will be impacted. Okay, so let's assume that I have a 6 node cluster. In this scenario, okay, 2 nodes went down. Let's assume that 2 nodes went down. No problem. Still, I have 4 nodes, which is more than 50%. Still, my cluster will be able to survive and it will process the data and everything will work as usually. Okay. What if you can ask me a question here? What if 3 nodes went down and 3 nodes are up and running? Now, exactly 50% of my cluster resources went down and 50% of my cluster resources are up and running. Then what is the scenario? How cluster will respond and how ONTAP will consider if it is how it consider that cluster satisfied the quorum or not satisfied the quorum. So here, whenever you come across these kind of situation, there is another thing called epsilon, which will come into picture. Let's talk about epsilon now. Epsilon. So this epsilon is a virtual entity which will be hosted on one of the nodes in cluster. Okay, which will be hosted on one of the nodes in cluster. So what epsilon will do, for example, I'll give you a real scenario, which will occur in our real life. For example, you know, parliament and assembly elections, right? For example, two of the oppositions, okay, two parties, they got same amount of seats. For example, let's assume that we have 200 seats. Okay, both the parties got 100 and 100. Now, which one will form the government? Governor or president, they can cast their vote. Okay, whenever this kind of situation occurs, they have to cast their vote. Okay, so for example, governor elected one party A, then they'll form the government. If he choose party B, then it will form the government, right? The same kind of thing will happen here. For example, if this epsilon is on top of one of the surviving nodes, then cluster will be not shut down. Okay, the nodes will not goes down. The whatever the up and running, they'll still keep on up and running, and they'll be able to serve the data to clients. And my entire cluster will run as usually. For example, accidentally, okay, my epsilon is on one of the nodes which went down, then it will shut down remaining nodes which are up and running also, and it went down because epsilon will also considered as a node. Actually this is not an actual node, but they have designed, I mean they have introduced this only, uh, which will come into picture in this kind of scenarios where 50% of my resources are up and running and 50% of resources went down, then epsilon will play crucial role. We'll call this as simple majority. Okay, the 50% of resources are up and running, 50% of resources are not running. We'll call this concept as simple majority. So whenever cluster has to survive, it has to always satisfy the simple majority concept in quorum. Okay. Any questions, guys? So epsilon will play very crucial role. Okay, if you don't have any questions, then yeah, let's see how to find the epsilon. Okay, let me go back to admin mode. So if I run cluster show, see, I'm just seeing the node name, health, and eligibility, only 3 fields. But let me go back to advanced mode again, and let me run the same command, cluster show, which will show me the epsilon as well. See, epsilon. And as and one more thing, guys, the simple majority, quorum, epsilon, all these things will be applicable to a cluster which is having 4 nodes or more than that. If your cluster is just a 2-node cluster, then you don't need to worry about epsilon or you don't need to worry about a quorum. These conditions will be not applicable to 2-node cluster. Okay, because even if one node went down also, it will be like 50% of resources down, right? That is the reason they excluded 2-node cluster or a standalone cluster from these conditions. These quorum and epsilon, these concepts will be applicable to the clusters which are having 4 nodes or more than that. Okay, that is the reason I'm seeing false under epsilon. That means epsilon is not there on both of my nodes because this is a 2-node cluster. If your cluster is a 4-node, then you'll be able to see true here on one of the node, in front of one of the node. That means epsilon is posted on that particular node. Okay, let me see if I can find any lab which contains 4 nodes. Let me see that so that I can show you. Maybe in your versions they might have introduced a 4-node lab. Earlier we used to have, but now we don't have that. No, single HA pair only. We have, but again, 2 clusters. These are not a single one. Okay. Yeah. Okay. Not an issue. Nothing. What you need to do, cluster, for example. And one more thing, guys. I just want to state that. Okay. For example, as I told you, I have 4 nodes. Okay. Now epsilon is on top of my node 1. Let's assume that epsilon is here. Okay. Epsilon is on my node 1. Okay. Now I just want to reboot my node for on-tap upgrade or for to I want to shut it down to replace some hardware, but I have epsilon on top of this. So whenever you are trying to shut down the controller which is having epsilon, what you need to do? You need to move the epsilon from that particular node to another node before shutting it down or before rebooting. That is the best practice you have to follow. Okay, because if you reboot it or shut it down by hosting epsilon itself, it will take the epsilon also down along with the physical node, right? Which will be considered as a two nodes went down according to on tap. Okay, so that it will create unnecessary panic. And at the same time, if one of the remaining three nodes went down also, then it will consider that three nodes went down as where it has my cluster has not satisfied the quorum condition. It will bring the remaining two nodes also down. Okay, which will create outage. Okay, so that is the reason whenever you want to reboot a node which contains epsilon, it is best practice to move to a different node before shutting or rebooting that particular node. Okay, and one more condition here. So for example, here now it is on node 1, right? Node 1 and node 2 are HA pair, and node 3 and node 4 are HA pair. Okay, now when I'm moving the epsilon from node 1, then it is best practice to move this to a node in a different HA pair. That is the recommended. There is a reason behind that, like why they are recommending to move to the node from different HA pair. Because whenever you are rebooting the controller, the responsibilities of the controller has to be taken care by partner, right? So my partner node will get additional responsibility. On top of that, if you host epsilon also on that node, it might there are chances that even this node will also goes down because of the burden we are putting on that controller, right? So again, it will be unnecessary of taking a risk. So that is the reason whenever you are moving epsilon from one node to another node, NetApp will recommend you to move the epsilon to a different HA pair node, the node in the different HA pair, so that the impact will be very minimal. Okay, did you got it? That means whenever you are rebooting node 1, move the epsilon to either node 3 or node 4. Don't do it to node 2. Okay, no. Yeah. So let's assume that now my epsilon is on node 1. So how to move the epsilon to from node 1 to node 2? Nothing. Cluster, modify. I want to move from node 1, right? So node 1 and here epsilon. Epsilon, you need to set it to false on node 1. Okay. After that, cluster, modify node 2 epsilon. You need to set it on true. I mean on node 2. Normally it won't allow now because we have only two nodes, right? That's why I told you. Okay, then epsilon will be moved to node 2 so that you can reboot the node 1 like that. Just like example I'm saying. Okay, this is how you can move the epsilon from one node to another node. Any questions? Okay, else I can cover today small topics because I don't want to start big topics today, vServer and all, because we don't have enough time, and again it will put extra burden on you guys. Okay, then or else let's stop it for today. Okay, again we'll do it tomorrow. Tomorrow we are going to start a topic called vServer, which is very important, heart of NetApp cluster. Okay, without vServer, you'll be not able to do anything. You need a vServer to do everything. Okay, so don't skip the class for tomorrow. Okay, hello. Thank you guys. Practice the labs every day. Okay, whenever you have free time, just spend half an hour. You will be able to finish the practice. Okay, thank you. Have a nice day.